Alright, welcome back, class. Hopefully y'all enjoyed the easy one. This part, we are in for a ride this section. I'm just going to call it coordinate proofs. They can start out easy, and maybe it's my laziness kicking in, but I'm going to skip the easy ones. Y'all can figure out the easy ones, okay? I'm going to do... I'm going to do some. Let's go with that. Or at least 2, maybe 3. This is number 7 if you're using my book. The triangle one. And they give us the origin. They say this is S, 0. And they want this. They say it is an equilateral triangle. Alright, so how do you find that? I'm going to assume I'm going to have to split it. Right? So if I split it, that means this would be S over 2, right? 0. This is S, 0. And we don't know that. We know that this angle here, right, it's equilateral, so that is 60 degrees. So this whole distance there is 1/2 S, right? If this whole thing here is S, from here to here, that's 1/2 S in distance. And so if this whole thing is S, equilateral triangle, this whole side here has to be S. So we have 1/2 S, S, right? So far this is looking like our 30, 60, 90 rules, right? Where this is the short leg, hypotenuse is double the short leg. Well, that means this coordinate, right? Or not coordinate, but height, right? Long leg is short leg times square root 3, and then we just saw earlier that hypotenuse is short leg times 2. So the short leg times 2, hypotenuse. My long leg, which is what I'm going to find here, is short leg, which is 1/2 S, times square root 3, or square root 3 times S, or S square root 3 over 2. So that's the height, and you just saw I split it in half there. So the x-coordinate is 1/2 S, and the y-coordinate is S square root 3 over 2. Boom shakalaka. Not bad, right? Do I want to do... I'm going to do the harder one, which I think is part number 8. And maybe you guys can use some of that theory to help find number 7, part B. Part B? Oh, what did I do? I was doing 9? I know. The wrong mission number 5. Oh, dang. Well. Alright. Maybe I will do 7 the other part. This whole time I thought I was doing this one. Oops. Question mark, comma, 4. Question mark, 5, 0. And this, which is 0, 0. Alright, so do y'all agree that, let me draw this shape off to the side. This distance is 5, right? Okay, so I'm going to call this x1. We don't know how far it is from here to here. We don't know how far. x1, but it's 4 high. This distance, it's a rhombus, which we know a rhombus has all the sides are the same. This distance from here to here should also be 5 if it's a rhombus, starting from that coordinate 0, 0. So I'm going to use the distance formula. See, now you're seeing why this distance formula thing came into play. Right, distance formula, x2 minus x1 squared plus y2 minus y1 squared, right? So, parentheses, we're going to say, which one are we starting with? What's I'll call that? Fine. x1, y1, and x2, y2. So, if I do x2, 0, minus x1 squared plus y2, 0, minus y1, 4, squared, you get negative x1 squared plus negative 4 squared equals x1 squared plus 16. However, that distance, right, should equal 5. So, things get crazy. I'm going to square everything. 25 is x1 squared plus 16 squared. Subtract 16, x1 squared is 9, which means x1 is a square root of 9, which is 3. So that means this part is 3. That means if this is 3, and this distance, right, from here to here is 5, that x-coordinate is 3. That means if I add 5, I get 8. 4, 8, 4. So those are my coordinates. 3, 4, 8, 4. Shazam! Do I do 8 even though I basically just did it for you? I guess I can. Why not? Oh, this is actually number 9. Hot dang! Man, y'all better... Y'all better do well for me, because I'm doing nice things here. What is that? A, comma, 0. This is question mark, comma, B. And this is question mark, question mark. Obviously that's 0, 0. Alright, so, find those things. It's just not nice because there's no numbers. But, this is A long, 0 to A. That means this has to be A long, right? So if I call this x1, y1, x2, y2, using the distance formula, distance, x2 minus x1 squared plus y2 minus y1 squared, you're going to get x2, 0, minus x1 squared plus y2, 0, minus y1 squared. Reduce that, minus x1 squared plus negative b squared, which is x1 squared plus b squared, right? But all that equals a, that whole distance. But I need to find some things. So I'm going to square everything to get rid of the square root. So I'll have a squared equals x1 squared plus b squared, right? I want the coordinate of x1. Dude. So get out of there. So x1 squared is a squared minus b squared. I don't want x1 squared, I want x1. Take the square root. So x1 equals the square root of a squared minus b squared. So that little dude right there is the square root of a squared minus b squared. Alright, we're getting there. We should know that this coordinate's b. Now, right, this coordinate there is a squared minus b squared. I have to then go a long. I'm starting here, but each side is a long. So if I start here, that one is a squared minus b squared, but then I have to add a to it, plus a. So this whole thing is the x coordinate there. And that is the doozy problem. Got it? Get it? Got it. Good. I'll see you. I don't know when I'll see you, but adios.